Hello, my name is Mr. Bear Snuggles Fluffy Bitkins. Sometimes I like warm hugs. Let's do math!
Oh no, he's on the floor. Hi, I'm back. Were you afraid that you lost your teacher? Never be afraid. Never be afraid. We're at section 1 point whatever. I don't even know. It's the last one in the first module. So let's do it. 1.5, 1.4. Anyway, so we're going to compare functions across representation. So we've been learning a lot about these different types of functions, how we can move them around, how we can manipulate them. But data comes in all different forms, right? And so this whole section is going to be a little bit more realistic, as other than like things that you might actually see in the real world. So let's look at those. So for example, Brian and Felix are football players practicing their punting skills. They agree that their practice goal for the day will be to improve their maximum height of their punts. At the end of practice, they compare their highest punts because, you know, it's super easy to just track that. I don't know. Anyway, the height of Felix's highest punt is modeled by this graph. So what mathematical question? So of course we would need to know Brian's model. And for some odd reason, again, practically speaking, I don't know how the difference happens, but we have a graph of Felix's, and then we have an equation of Brian's. So using these two different informations, we need to be able to compare the two to figure out which one has the maximum height or the higher height. And of course, they're the ones we're going to get to play on Friday or whenever the next football game is next year or whatever. Let's go. All right, let's get started. So we're investigating properties revealed by different function representations. So there's four main types of way that you can express a function, and they're kind of obvious, I guess, but it's kind of nice to actually see them laid out in an organized fashion like this. So you can have a verbal description, which is, you know, just words, descriptions, whatever. You can have a table, so you have like a table of x values and a table of f of x values or y values. You can have a graph, and you can have an actual equation. So four different representations of a function are shown. So here's an example. So I think these are all using the same function, if you will. So verbal description, the function is a vertical compression of the parent quadratic function by a factor of 1/2. Its vertex is -1, -2, and its end behavior is y approaches infinity and x approaches plus or minus infinity. Y approaches infinity as x approaches positive or negative infinity. So it's a normal parabola that goes up. So then we have our equation right here. Then you can use that equation. We've got a graph, a very tiny little graph right there. It's so adorable. And then we have a table. Again, we've got our x values and we've got our f of x values. So we can figure out all of these values based on the chart above. So what are f of -1? So my first thing is I'm going to look at this chart. F of -1 is -2. Cool. Too easy. F of 0, so if I look at my chart, I don't have a 0. So I can plug it into my function, or I could even look at my graph here. F of 0 would be that part right there when x equals 0. Or if I plug it in up here, that zeroes out, and you just have -3 halves. And then f of 2, when x equals 2, we can follow it up here, and it's right in between the 2 and the 3, or we can plug it into here. But either way, it is 2.5 or 3 halves. Wait, what? Okay, fine. F of 2. Let's plug it in. Well, no, I'm looking at my graph. So halfway between 2 and 3, so that would not be 3 halves. What are my other options? That would be 5 halves. My bad. They plugged it in and everything and did math. That was probably the better way to go, but whatever. Explain how you determine each of the value in part A. So, I talked through about where I found all those values. I used a variety of different, if it was on the table, great, I can use the graph, or if I need a precise answer, I can use the equation. I did not use the vertical description, but hey, whatever. How would you find the vertex, maximum, minimum values, intervals of increasing, decreasing, and intercepts given the vertical description by itself? So the vertex, the vertical description gives you the vertex. It gives you the end behaviors. So from there, you can figure out your maximums and minimums. Since your y approaches infinity from both x and y, x is negative and x is positive, there's no maximum, so there would only be a minimum at the vertex. So I'm basically just logicking, rationalizing all this stuff out as I go. So everything to the left of the vertex is decreasing as it's going down. Everything to the right of the vertex is increasing as it's going up, and so on and so forth. For the given verbal description, if that is the only information you have, can be used to describe the symmetry of the function. So no, technically. Actually, yes. Because since it tells us it's a vertical compression of the parent quadratic function, we know that it still maintains its symmetric properties. So yes, there's going to be a line of symmetry that goes through the vertex. And for the given table, if that is the only information that you have, can it be used to describe the symmetry of the function? It can come close, but if you're looking at that table, it's hard to see. But you can kind of see a pattern here. So like -1, -2 is your vertex, and we have 0 and 6. So you can still kind of see that there's some symmetric values there. So you may need to convert from one to the other type of method of showing these things. So let's see here. If two functions are present using different representations, you may need to convert one or both of the functions to another representation before comparing properties. So the function g is a vertical stretch by a factor of 2 of the parent absolute value function, followed by a translation of 2 units left and 3 units up. The function f is an absolute value function represented by the table. Oh, so there's a different function of the values below. Which function has a greater minimum value? So with the table, it's very easy to see what the minimum value is. If it's an absolute value, I would assume the minimum value would be somewhere in between 0 and 2 here at 5. So, somewhere around like 4 or something like that. Let's see here. This one, it's a vertical stretch of the parent absolute value function followed by a translation, 2 units left, 3 units up. So the minimum for this first one is 3, because it only moved 3 units up. So the vertex is going to be at y equals 3. The vertex here is probably going to be around 4, but it's hard to say. So method 1, use the given representations. The parent absolute value function has a vertex 0, 0. Which statement best describes how the vertical stretch of a parent absolute value function affects the vertex of G? It would not affect the vertex at all. does not affect the vertex of the parent absolute value function. So then translate 0, 0 left 2 units and then up 3 units. What are the coordinates of the vertex? So x is going to be -2, y is going to be 3. So the minimum value of g is 3. Look at the pattern of the values for table of f. What is the vertex of f? I'm going to say, what did I say, 1, 4? Yeah, I'm going to say 1, 4. So there's a pattern there. And since we now know the vertex 1, 4 and the vertex -2, 3, the minimum or the lowest one of the two functions is the vertex at g. So the minimum value of f is 4. Comparing the two values, the function f has the greater minimum. Use common representations. Since f is represented by a table, the given ordered pair can be plotted and used to draw its graph. To graph the function g, first create an equation using the verbal description. And so then you would go through and just step by step figure out what each one is. So let's do another one. Compare functions given using different representations. So 2 teams are launching pumpkins. Great. The height, h of a, in feet, of team A's pumpkin is given by the equation shown. Right there. Where t is time in seconds since launch. The height of team B's pumpkin is shown by the graph. Right there. How do the maximum heights of the 2 teams' pumpkin compare? So this is your graph. Your maximum height, you can clearly see, is right here. And so now we would need to figure out where the maximum height for here is. So method 1, use the given representations. Let's see what they're asking for here. The function is quadratic. The maximum height occurs at its vertex. The vertex of a quadratic function, blah, 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 occurs at x equals -b over 2a. I actually wrote that down in my notes over here because I knew that was coming and I always forget that formula. So find -b over 2a. Come on, zoom in. You can do it. So we've got -b, this is our b, over 2 times a, here's our a, -16. I'm just going to put that in my calculator. Don't tell anyone. And I'm not going to add negatives because the negatives cancel out. So there's actually, this is a great opportunity to learn how to use your calculator. So notice how it's 56 over 2 times 16. So there's 2 ways you can enter that into your calculator. There is, you can do 56 divided by 2 divided by 16. And you get your answer, 1.75. Or you can do it by using parentheses, 2 times 16. So again, your calculator will do the parentheses first to make sure that happens. Now this way up here is going to be really useful in like science class or chemistry, just when you have just a bunch of stinking numbers, you know, some of them are above, some of them are below, and you can just enter them all in your calculator and you don't necessarily have to think about order of operations. You just put the right sign or the right operation in front of them. So either one works. For now, it doesn't matter as long as you know what you're doing. That's probably the more important part. What was it, 1.75? I already forgot. Yeah, 1.75. So here we go. Oh, of course they have a fraction. So that one. Yay. Look at all that math that we did. So then find HA of 7 over 4. So we're basically taking that and we're plugging it into this equation. right here. Do they do the math for me? Nope. So if we take, what was it, 7 over 4? So negative 16, 7 over 4 squared plus 56 times 7 over 4 plus 18. This is still, I mean, yeah, y'all can work that out, and it's something good that you should be able to do, multiplying fractions by each other, but I'm not going to do that here. So negative 16 times 7 over 4 squared plus 56 7 over 4 plus 18, boop, 67. I'm so good at basic math. 67, so then we can come down here and go, boop. Yay! And of course they show us all the math there. So the maximum height reached by Team A's pumpkin is 67 feet. The maximum height reached by Team B's pumpkin is what, 70 feet? Yeah, 70 feet. So then that means that Team B wins. Yay. So another way that we could have done that, close it, is by using a graph. And so, you can either graph both of them by hand, or y'all have like super fancy graphing calculators. You can actually put both equations. Oh, you only have one equation. You would put this equation into your calculator, and then you could compare graphs like that. So that is another way that you could do it. But you're done. So check out the Check on Learning and test yourself against that. And obviously, if you need help, there's a video for it. Either way, I will see you in class.